pump system is off. Two, investigate the height in centimeter on calibrated container on the rate of water flow in cubic centimeter per second when the pump is on. Advantages of this project. 1. It reduces water through spillages. It creates employment for the people that makes this project. It reduces water bills where there is water overflow. It has no current over water. Materials of this project. We have the framework, MDF board, measuring 2.5 feet long and 1.5 feet width. We have 4 wooden stands measuring 11 centimeters. We have the MDF board 11 centimeter diameter, forming the framework where we place the calibrated container. We have the conductive sensors labeled A, B, and C, and others as illustrated in our display board. Procedure. We have 2 procedures for our prototype and to generate the results. Procedure for our prototype, my partner will take you through.
Okay, for procedure for the prototype, we have a procedure for the framework. You cut the framework 2.5 feet long by 1.2 feet width using a handsaw. To the right side of the MDF board, you attach 4 feet timber, and above it you attach a platform. To the left side of the MDF board, you put your pump system and attach 3 pipes to each pipe, P1, P2, and P3. But procedure for the sensor. You fit 2 circuit boards, a larger and a smaller one, to which you fix 2 state transformers.
Procedure to generate the results. When the pump is on, set up the pump system near to the water reservoir. Open the gate valve, and record the time taken for each to reach the conductive sensor A.
When the water level reaches conductive sensor A, the following are observed. The blue LED bulb will turn off, and the water will stop automatically pumped into the 20 liter calibrated container. When the gate valve is turned on, the following are observed when the water level reduces in the 20 liter calibrated container. The blue LED bulb will turn on, and the pump will be automatically turned on, and water will start flowing into the 20 liter calibrated container.
Conclusion of this project, such as
The objectives of LAB aim to develop an automatic access water detector system that effectively measures and controls the amount of water usage within a specified time frame. By implementing this system, real-time observation of water usage can be achieved. Consequently, the automatic access water detector system serves several benefits, including the prevention of water usage and the ability to promptly identify and control any deviation from the preset targets.
the limitations that we face in this project are such as the pump system cannot work when there is no power supply. The pump systems cannot pump water beyond 8 meters high. This is because the pump system can pump water up to the maximum height of 8 meters. The pump system has no mechanism to purify or to test the pH of the water. Therefore, we recommend this one. We recommend that our system can be further research to be done so that our system can be solar powered, hence the vulnerability of the power outage. Secondly, we call further research to be done so that our system can be mechanized to purify or to test the pH of the water. We call upon further research to be done also so that our system can pump water beyond 20 meters high or higher, especially in arid and semi-arid areas. Acknowledgement.
We would sincerely like to appreciate the following: our Chief Principal, Mr. Cyril Innocent, for the financial support he gave us, our lab technician, Mr. Benedict Nabuana, for helping us go through the procedure, and our assistant lab technician, Mrs. Elizabeth Ogwal, for helping us access the lab equipment we need for our project. Thank you.
have decided to come up with greenhouse gas sequestration, which can help in solving or contributing to solving the climate change, and also to reduce the greenhouse the increase in global warming. So our project aligns with SDGs, I think that is climate action, and it also aligns to the government manifesto that is the bottom-up government exercise uses a greenhouse source of energy, a solar panel, and it also aligns with Vision 2030 that the government wants to attain a zero net emission by that year.
The objective of us creating this project is to reduce the rate at which global warming is increasing and also to facilitate transition of industries towards clean energy processes.
The advantages of this project, it is eco-friendly and it is also cheap to maintain.
Scientists, however, the one that we trying to come up with innovations to deal with this issue of emissions and also carbon emissions in the atmosphere. We have been able to come up with models such as the pre-combustion, the post-combustion, and the post-fuel combustion technologies to deal with this issue of emissions. Although these methods prove to be helpful in reducing the emissions in the atmosphere, they prove too expensive to construct and maintain. And so, using our chemistry knowledge, we have been able to come up with an innovation that can fix this problem of emission from the chemistry part of it. The chemical principles applied in these projects are chemical absorption, which happens in our chamber 1 here, where the smoke with the main component, the carbon smoke with the main component of smoke, so forming about 75% reacts chemically with water to form a weak carbonic acid. The weak carbonic acid is taken to our chamber 2, where it is heated in order to be decomposed to form water and carbon dioxide.
So the overall current plants are around 400 nuclear power plants produce around 10% of energy that is being used. So therefore, the Kenyan government has decided to plant a nuclear power plant in Cliff, which is expected to produce around 820 gigawatts of electricity. Despite of the positive contribution of the nuclear power plant to the economy of Kenya, it is also expected to produce smoke that the government has not yet addressed. Therefore, greenhouse gas sequestration can be used to cap the smoke that will be emitted by the nuclear power plants. So here, we have an improvised industrial chimney. We have a round bottom flask. We have these two 500 ml flasks, and we also have a battery here, so which we use to power our fans. So here, we'll just light a paper, which will produce smoke. That is the smoke that is being emitted by the industries. Pump the smoke to react it with water. Through the chemistry principle that is absorption, we will heat it sometimes we hatch, then we will pump it to the decomposition chamber, that is our chamber 2. And then we will end up making a massive manner that to decompose to separate the carbon dioxide and water, then we store carbon dioxide. It can be used in traditional supplements. It can be also used in greenhouses. We have that shown in your like we shall expect against to turn into precipitates to perform the process of carbon dioxide. It has already started turning away precipitate. So here, according to the UN report that it was given 2023, shows that in the year 2011 the carbon emissions to the atmosphere was 250 million metric tons, and the year 2022 the carbon emissions to the atmosphere was 3,250 million metric tons. That is an increase of 3,000 million metric tons in only a span of 12 years.
Its further research has shown that the main source of these emissions are electricity and heat, for example, nuclear power plants only about 55%, agricultural practices only about 24%, and industries only about 21% of these emissions, contributing to 21% of these emissions. And so this increase is expected to continue unless a lasting solution has been found to deal with this issue of emissions in the atmosphere. In conclusion, we conclude that this project was able to achieve its objective of reducing the rate at which global warming is increasing
since we are capturing the carbon, which is one of the main greenhouse gases being released into the atmosphere. And also has led the industries to more greener energy practices because their industries will be doing the industrial practices and will not be producing any smoke into the atmosphere. We would like to recommend the government to implement policies on industries that emit carbon into the atmosphere to adapt to carbon capture technologies, and also like to recommend, we would also like to create public awareness about carbon capture technologies and their usefulness in mitigating climate change. We feel obliged to give special thanks to the Almighty God for giving us brain to come up with this idea, and we also give thanks to our chief principal, Dr. Laman Gary, who fully funded our project, and we also express our sincere gratitude to Dr. Mosi, who did not only guide us but also given us a platform to do research, and our HOS, Madam Nancy, who allowed us to participate in this. And also, since the program is already full, we just pump it back in order to save money. Instead of keep replacing the water, we can just pump it back to our Chimawa so that we can integrate it.
Welcome to the 61st edition of the Kenya Science and Engineering Fair. I am a Nairobi region for the schools established by the president of a project entitled Using Magnets to Enhance Plant Production. I am over here with Anshad along with the presenter to present our project. Now, there has been a recent problem of increasing food insecurity and soil degradation and high use of synthetic fertilizers and pesticides. We want to use magnets to solve that problem. High use of pesticides and synthetic fertilizers cause long-term soil degradation and lead to poor soil health. Thus farmers struggle with poor crop yields and also our small-scale kitchen gardens in our country of Kenya. We want to use magnets by integrating them into food production. We want to use magnets to enhance plant growth for food production methods by putting them into the soil and how magnetic fields affect plant growth. Now I'd like to hand over to Dr. Pandya to explain the objectives of our project.
Our main aim of this project is to empower women and youth. We want them to grow plants and help in increase of food production. We also want to align this project with the SDG goals, the Sustainable Development Goals.
Now, how does magnets affect plant growth? Now you see, when you put magnets into the soil, they cause interference. When a strong magnetic field and a weak magnetic field on the earth interfere, they cause a process called motor current. Now you see, ions, spelled as ions, they are charged particles in water and soil. When magnetic fields are introduced to them and the interference of two magnetic fields happen, they cause luminescent discharged particles. And since the stronger magnetic field is the one with the magnet that we are put into the soil, the charged particles will move towards the stronger magnetic field. And then, since the magnets are near the plant's roots, the particles will hit the plant's roots and they will get absorbed into the plant, leading to increased water absorption, nutrient uptake, leading to strong root development, stronger plant growth, a healthier plant, and faster plant growth, which will also help the seedling break out of its dormant stage faster due to its increased water and nutrient absorption. Now I'd like to hand over again to my co-presenter, Arya Pandya, to explain and take us through our procedure.
How did we do this project? Basically, what we did is to take similar material of crops. So to make this project fair enough, so that we get accurate results, we
and the tools can actually positively influence plant growth without any use of chemical fertilizers. And so we are also reducing dependency on chemical fertilizers by mitigating or innovating initiative.
One more thing that we observed in the results was that the ring magnet, there are different types of magnets. There's bar magnets, there's ring magnet, there's ring magnet. This ring magnet was given also, like we used it also to plants. It showed us the best results. This ring magnet is circular. Now when we plant the seeds normally, the attraction they get is from all sides. So they get better results. This is the best type of magnet we can use to plant. I also want to say that when we put magnets in the soil and then we water the plants, because water is really essential for plants to grow. When we put this magnet into the soil and then water the plants, when the water touches this magnet will start corroding. So to prevent corroding of the magnet, we use insulated tape to cover the magnet so that the magnet stays waterproof and it does not corrode.
In the end, we would like to acknowledge many people. First of all, we would like to thank God for providing us with basic opportunities to participate in this data science and engineering fair. Next, we would like to thank our principal, Mr. Sharma, for providing us the platform and financial and support to carry out the project. Then we would like to thank our supervisor, Mrs. Kerai, who guided us all together and took time out of our busy schedule for our project. Lastly, we would like to thank our parents and our system advisor, Madam Shivan, who always encouraged us and also guided us through our project.
He also ensured that the system was fit to use and we can use the system to actually do this project.
Thank you.
Welcome to this first edition of the Kenya Science and Engineering Factory Hub. I am a presenter, Nathan Moura, and I am presenting to you the Smart F-Cut. Now, future environments is often marked with inefficiencies such as long queues in the technical company and also environmental pollution using the different seats. The Smart F-Cut makes use of the RFID and GSM technologies to overcome these challenges while addressing sustainable development, which is responsible consumption and production. For our prototype, we use the LED screen, the toggle switch, the power switch, and we also have our products and the shopping cart model. Our cart uses the RFID technology to scan the products and display the products status and price. The products that are scanned using the RFID scan. The GSM module will send electronic receipts to the customers, therefore enabling the paper receipts to be a thing of the past. This project is an improvement to the shopping environment in that it is a demonstration of innovative solutions to outstanding challenges in the retail environments. Number two, we want to be using calculators when going to the supermarket to calculate the total amount of prices. And number three, the adoption of the GSM module and the electronic receipt is enhance environmental sustainability because it has indicated the need for the paper receipts. We also acknowledge that this prototype has limitations in that since we're using the GSM module, the electronic receipt will be delayed to reach the customer's phone in real time. And therefore, we ask further researchers to develop a system that will develop an alternative to the GSM module in case of failure or network coverage issues. I want to acknowledge the following. First, I want to acknowledge God for bringing me this far in this competition. Number two, I want to acknowledge Sans Patron for helping me in getting my write-up and also showing me what to do and the objectives of this project to forward. And also want to acknowledge our principal, for helping us acquire the required materials such as the Iberian body should not have gotten by ourselves. We also want to acknowledge our computer teacher, Mr. Tachometer, for his aid in the coding bits of our project. Thank you.
So welcome to the 61st edition of the Kenya National Student Science and Engineering Fair from Nyanza region. I'm Murad Farhat and my partner, Odero Bawari. We are from 3 students from Senior Girls High School and we came up with the project titled Smart Crop Storage Monitoring and Management System under the category Agriculture. Effective crop storage is vital for reducing post-harvest losses and ensuring food security. This project introduces an automated crop storage monitoring system, a smart solution that monitors environmental conditions and enhances security of storage facilities. In Kenya, post-harvest losses are a significant challenge facing agriculture, particularly in developing countries, where inadequate storage conditions lead to spoilage and waste of essential crops. Crops such as grains, fruits and vegetables are highly susceptible to environmental factors such as inconsistent temperature, excessive humidity, poor light regulation, and gas breathing. Manual inspections are also labor-intensive and often fail to detect problems early enough for corrective actions. Addressing all these problems require innovative and cost-effective solutions that integrate technology. We have 3 objectives for our project. Our first objective is to develop a low-cost efficient crop storage monitoring system that monitors and optimizes storage conditions, to implement real-time data transmission by use of Bluetooth technology, to enhance security in storage facility by incorporation of PIR motion sensor.
So for our apparatus, we use an Arduino Uno V3, which is the main processor of the system, a DHT11 that measures temperature and humidity, an M2 gas series sensor that detects harmful gases in the storage facility, a PIR motion sensor that detects intruders in the storage facility, a blue LED that shows normal conditions in the storage facility, a red LED that shows high-risk conditions in the storage facility, a buzzer that produces an audio alert in case of high-risk conditions in the storage facility. We have a Bluetooth module that sends real-time data to the nearby farmer's smartphone.
This is how the system works. We have the Bluetooth module that sends the data of the condition that is happening, of what is happening in the storage facility to the nearby farmer's smartphone, indicating the conditions such as temperature, humidity, and gas level. All the condition that is being monitored by the Bluetooth module is being sent to the farmer's smartphone. This will enable the farmer to know the condition in the storage facility anywhere, anytime. We have the SSR4 ultrasonic sensor that measures the height level of grains in the storage facility. For example, in a silo that we have here, a farm may decide to bring maize using a lorry and pour inside here. The maize may pour out.
To prevent the pouring out of the grains, we use the ultrasonic sensor to detect the height level, then alert the farmer that the silo is full. The farmer should use the next one. As you can see, if you check the liquid crystal display, it will show you that the silo is full. Use the next one. We have the PI motion sensor that detects unauthorized movement in the storage facility. It will alert the farmer that there is an intruder in the storage facility, and it will send also to the farmer's smartphone, so the farmer will know that there is an intrusion in the storage facility.
So this system effectively alerts the farmer in case of temperature and humidity deviation, allowing the farmer to take corrective actions such as ventilation adjustments. We also came to know that these parameters such as the temperature, humidity and gas levels fluctuate in response to environmental factors such as time of the day, weather changes and storage activities, necessitating for regular monitoring to ensure optimal storage conditions. This, however, introduces the Bluetooth modem which can help the farmer to monitor the silo anytime, anywhere. For the motion detection and the intruders, we have the PIR motion sensor which will alert the farmer in case of such things.
In conclusion, the automated crop storage maintenance system represents a transformative approach in addressing foodstuffs losses and ensuring food security. Introduction of the surveillance sensor and increased gas sensor help in optimization of the storage condition, minimizing spoilage. Integration of wireless data transmission via the Bluetooth foster ease of monitoring, making it accessible to small-scale farmers, hence reducing reliance on complex infrastructure. This innovation directly supports Millennium Development Goal 1, which aims to eradicate hunger and poverty by mitigating food wastage and maximizing resource efficiency.
However, our system is not 100% efficient. It has two limitations, and the first one that it depends on stable power supply, and in case of any interruptions, it may lead to data loss. The second one is it has a limited Bluetooth range. We recommend coming up with a more advanced system that uses power backup such as renewable energy and IoT integration for broader data accessibility. We also recommend developing mobile applications for easier monitoring, alert notifications, and better user interactions. Aligning with the Vision 2030, policymakers and stakeholders should integrate this system into national agricultural organization to reduce post-harvest losses, poverty, and enhance food security. We would like to thank in the kindest way the Sinologas High School staff for the technical as well as equipment assistance that helped us generate data for our project. Special thanks to our principal, Dr. Teresa Date, for the financial assistance throughout this project. Finally, this section will not be complete if we did not thank our patron, Mr. Joseph Odiambo, for his constant counsel, along with his willingness to share knowledge despite his busy schedule. Thank you.
Good morning, my name is Jeremy Manzara, and my partner is
I'm Bisaka from College Secondary School.
and we're here to present our project for the utilization of those papers in Kenya.
The disposal of diapers poses a significant environmental challenge due to the biodegradable nature and the large quantities needed to discard the animal. It all started in the 1930s when a UK company known as Johnson first invented the cloth diaper. Later, in 1941, a Swedish paper company thought of the idea of putting paper that inside the cloth as an alternative. Now, in 1942, Maradona invented the first disposable diaper. A recent research shows that a disposable diaper roughly decomposes within 500 years. Over 1 million babies born each year. Kenya's annual diaper consumption is estimated over 800 million pieces. This might lead to a great plastic pollution. And there comes our project, utilizing those diapers in Kenya. Our main objectives for this project are for the production of an alternative source of fuel and also to produce those and other items for the outer diaper families. My partner will take you through the procedure.
As you know, Kenya will be depending on the fossil fuel for a long time. These fossil fuels have been affecting our economy. version became aesthetic, our economy took a great hit. So we took that into consideration and therefore used diapers to create substance equals to the material we needed used diapers, from used diapers required to the messages. We needed 100 ml of ethanol, 5 ml of acetic acid, 2 liters of 250 ml aspirin gold, thermometer, sulfuric acid. So we first collect the diapers, then we sort and clean them out, we cut and load the seeds to extract sodium polychlorate. The sodium polychlorate we weigh 100 grams, then we add it into a beaker. In the beaker we add 5 ml of acetic acid, then we stir until sodium polychlorate is soaked, then we add ethanol, 100 ml of 70% ethanol, and there we form a gel. The second part of our project is production, using the outer fabric of the diaper in various ways as the classmates mentioned.
As he said, we extend the senior period from the waste diaper. Now, our project being documented, we couldn't afford to throw back again the outer fabric of the diaper. Then we thought of the idea of taking these waste diapers, you knit a piece of cloth in a shape, and then after knitting, you knit all of it leaving one side open. After you finish knitting in a doll shape, now you take the outer fabric of the gel and now you put it inside. It can form dolls you can replace in water. Also, this outer fabric can be used in other items such as the clothes and in pillows, in furniture and etc. We observed after the production, we made an observation. The
observation is that using different concentration of ethanol will determine the efficiency of your gel. So we use our gel is probably using a 70% concentration. See, 70% concentration is come up by adding a little water into the absolute ethanol. Then there is a 50% concentration of ethanol. When you use different concentration, 50 will burn for 100 ml, the gel will not be efficient in such a way that it will require refilling because of this depletion. We also found that the amount of the used affects directly the amount of the messages. Like we use 100 grams. That is if you keep the concentration of ethanol and acetic acid constant, the sodium polychlorate is going to affect the gel. In our data collection, we needed to find out the environmental pollution caused by diapers in such a way that we compare the usage of diapers by different ages of kids. That 0 to 6 months are estimated to use around 8 diapers a day. And as you can see from our data in our display, 6 months to 12 use 6 diapers, 12 to 18 months use 5 diapers, 18 to 24 use 3 diapers, and 24 to 3 use diapers. And also, as you know, we have fuel that is currently in the market. That's what we call kerosene. The kerosene one burns with an aluminum flame, and we compare the time that kerosene fuels take to heat 100 ml of water to boil, and the time that the lacetate is going to take to heat 100 ml of water to boil. And as you can see from our result there, our gel heated the water to boil at 92 degrees with the water was degree, of course, at 92 in the 17th minute. But at 14th minute, the water was still at 83, and the water and the kerosene was still at 83 degrees, meaning that it was not yet, it hadn't started boiling yet. The recommendation of our project is
I would like to recommend the fabrication of a heat or a stove that can be used with this fuel of ours. Also, I would like to recommend for the further research of the conversion of waste diapers into a resourceful, into alternative source of fuel.
and we would like to acknowledge first the Almighty God, our teachers, Madam Oshira, Mr. Moses, and Mr. Kintai for their help and encouragement to do this project. Our friends, Patrick and Gabriel for their help in this project, not forgetting science fair project on Tachometer. Tachometer is a device that is used to measure horizontal distance. The idea of measuring horizontal distance came to me during a moment of observation and curiosity. I was studying in an open field where I was very determined how I can measure the horizontal distance between where I was studying to a distant tree. That is when the idea of property of a tangent to a circle came to my mind. Tangent touch one point of a circle and make 90 degrees with the radius of the circle. Through combination of properties of a tangent to a circle and trigonometry, I was able to come up with a formula on how I can calculate the horizontal distance. Early January this year, I introduced my idea to my friend Paul, and we have to do further research. In the field of surveying, triangulation is the common method used in measuring distance. Triangulation uses properties of trigonometry to measure the distance. Triangulation has been advanced to use of deodorite, which is an optical instrument that is used to measure the horizontal distance. Also, deodorite has been advanced to use of total station, which is an electronic deodorite that's used to measure the horizontal distance. According to Anderson and Mika, 2018, they state that the accuracy of triangulation depends on the reading. The first thing is the baseline measurement. The second thing is visibility of the station. And the third thing is the angular measurement. Due to these three limitations, triangulation is not preferred in the modern survey, according to Mika and Graham, 2017. In our science fair project, seem to explore how we can measure horizontal distance despite triangulation being commonly used in the modern survey. Our project have three main objectives. The first objective is to construct an equipment which we name it Tachometer to estimate the horizontal distance. The second objective is to establish a linear relationship between the horizontal distance and the reciprocal cosine angle between the horizontal line of sight and the radius. And the third objective was to establish a linear relationship between the horizontal distance and the radius, which is perpendicular to the target. And now my colleague can explain further.
Now, in methodology, we constructed an instrument which is named Tachometer. In constructing Tachometer, we used a wooden frame, 1.1 meters. We used two wooden panels, one at the bottom, another one at the top, to support our scale. We used a protractor 0 to 90 degrees to measure our angles. We used two transparent rulers which we joined with a half meter rule to act as our radius. We also joined two PVC pipes. The first PVC pipe was connected at the protractor on 0 degrees, which acted as our horizontal line of sight. The second PVC pipe was connected on the meter root, which acted as our tangent to a circle. Using our instrument, we were able to investigate two main variables. Number one variable was the independent variable. The first independent variable is the angle, where this angle is the angle between the horizontal line of sight and the radius. If you increase the radius, if you increase the angle by keeping your radius constant, the horizontal distance will also increase. The second independent variable is the radius. If you increase the radius by keeping your angle constant, the horizontal distance will also increase. By keeping our radius constant, which was 0.6 meters or 60 centimeters, we were able to investigate the variation of horizontal distance with angle beta. We carried out the experiment and we recorded our data in level 3.1. Then right now we can show you how this instrument of ours can be able to collect the data at level 3.1. First of all, you must move your target pole at a distance. Then first we view the target pole using our P1, which is our target, the horizontal line of sight. Then using our P2, which is our tangent, we rotate it until we view the the same point using our feed mill. Then after that, you record your data. First of all, you record the angle. Our angle is 67 degrees. We kept our constant 0.6 meters. So using our formula, which is horizontal distance x is equals to radius over cosine of angle theta, we can be able to calculate the horizontal distance, then we will prove it by measuring using tape measures. Our calculated horizontal distance using our formula, horizontal distance is equal to radius over the cosine of angle theta was 153.5. Our measured horizontal distance using our tape measure was 153.5. So our equipment can approve our equation, which is horizontal distance x is equal to radius over the reciprocal of angle theta. My colleague can take from there. Thank you.
In our project, we can recommend for two things. The first is use of digital protractor, which will enhance accuracy during measuring of angular measurement. We can also recommend use of infrared laser pointers, which will also enhance accuracy during measuring long distance. However, our science fair project has few limitations. First, it depends on a clear line of sight. That means that we are not able to measure horizontal distance where there is obstacles such as building activities. The second limitation is it is not applicable to all terrain. That means our project, our science fair project, is limited to measure only the horizontal distance. Also, the third limitation is it is not applicable to measure large distance. For one to measure large distance require a large amount of variance. We can acknowledge our patron science, Mr. Frederick Memory, for provision of advice, guidance, and expertise in our project. We also appreciate our able principal, Mr. Peter Kaboshi, for financial support. We also acknowledge our English teacher, Madam Lecture, for proofreading in our project. We also appreciate our peers, Nicholas Onyango, for supporting us during constructing Tachometer. Thank you.
Greetings to all. My name is Mark Blessing from the Organization National High School. Welcome to the 61st Kenya Science and Engineering Fair. My project, entitled the Smart Home Nursery, aims to use the current baby monitoring system that uses the current technology, such as the use of Arduinos and sensors to ensure comfort of the baby. As you know, parents nowadays have a difficult time to manage between their work and taking care of this baby. This is why we have come up with a project that uses moisture sensors and sound sensors so as to accurately detect when the baby has wet themselves or when the baby is crying, and thus uses the wireless communication such as the GSM module to send a message alert to the caregivers. So you may be asking yourself, what are some of these things that guide us in coming up with our project? We are guided by the following objectives. Objective number one is to develop an infant monitoring system that detects baby cries and moisture levels, sending real-time message alert to caregivers for prompt intervention. Objective number two is to develop a temperature regulation system that regulates the temperature of the surrounding of the baby by the use of a fan and a heater. Some of the scientific principles that guided us in our project is, number one, the sound detection and signal processing. This is whereby the cry detection by the sound sensors uses the scientific principle of sound wave propagation and signal processing. The other one is heat transfer. This is whereby the project use the principle of heat transfer. This is whereby heat moves from a high point of concentration to a low point of concentration, which is the key point when regulating the temperature of the surrounding of the baby. And so, the prototype use the following apparatus. So as you can see, we have a sound sensor, a moisture sensor, which are embedded in the cradle of the baby. Then we have a servo motor. Then we have an Arduino. Our project is fully dependent on the Arduino. And then we have a heater. We have two fans. We have a speaker. And so this project is fully depending on the solar tracking system. As you know, this is a cost-effective thing that, as you know, nowadays electricity has become so expensive. And so we use the solar technology so as even for those people where electricity has not reached, so that they can also be able to use these systems. And so our system detects baby cries and moisture levels, thus sending real-time message alert to caregivers. And it also, from the research done, we are able to see that the optimal room temperature for a baby is about 20 to 25 degrees Celsius. And so, as we light, we set our LED screen so that we can light our prototype. As you can be able to see that this fan has turned on. The system has detected that the room around is above the 25 degrees Celsius, which is set for this temperature. And so it has turned on the fan automatically so that it can regulate the temperature of the surrounding of the baby. Then we have some previous text messages. As you can see, when it detects a baby is crying or maybe there are moisture levels, maybe presence of moisture in the surrounding of the baby, it sends text messages to caregivers alerting them that either the baby is crying or the baby is wet. As far as our project is full for real-time world effect, we also encourage further researchers to embark on the same journey. So what are some of these things that we welcome these researchers to do? One of the things we welcome these researchers to do is that if there can be embedded a video camera so that these parents, whenever they are working or whenever they are in their, maybe doing their personal works, they can also be able to monitor the baby when the baby is sleeping or maybe whatever the baby is doing around the room, so they can incorporate video systems, and also they can even incorporate some of the systems such as things that can automatically put on fire. You can know that maybe the temperature fluctuations may be because of fire around the baby. So maybe if they can develop a system which can automatically turn off fire if there is presence of fire. And also we welcome these researchers to also embark on a journey where we can develop systems that may not require these GSM modules because of network connectivity. As you know, babies are very crucial beings. Such things like such as presence of moisture, maybe the baby has immunized on themselves, so maybe fluctuations of temperature, and there is delayed response. It may lead to diseases that may affect their whole time of life. And so, if there can be systems such as to develop systems that may not really require network connectivity, so as to send this message alert to caregivers. So, in conclusion, I would like to acknowledge the following people who enabled us to be where we are right now. So first of all, I'd like to acknowledge our son's patron, Mr. Stephen Yabira, for giving us the technical support, for always supporting us, for allowing us to be here, and thank you so much, sir. We'd also like to acknowledge our ICT club patron, Mr. Titus Maina, for helping us in the coding. We'd also like to acknowledge our Olaisa fraternity for giving us the financial support that we needed. Thank you so much.
Good morning, my name is Lemmy Martin and welcome to the 61st edition of the Kenya Science and Engineering Fair. This is my research project, real-time mobile communication system for exercise and education. Before I start on the action project, I'd like to ask you a very important question as to critical point in my research project. I've ever had a friend, a relative, or someone you just knew who had their KCSE exam results cancelled just because of the mistakes of other students. My cousin actually did his KCSE examinations a few years back, but when the results came out, he was very shocked to see that his results were cancelled because students from his school were putting funds in the examination room. This caused him to be very depressed because he could not do his course of choice at the university. So in order to combat such future cases, I embarked on this journey to develop a system that will be able to accurately detect the presence of a mobile phone within a 5-meter range of the model and be incorporated with a GSM module to be able to provide real-time alerts to the examiners informing them about the presence of a mobile phone. And some of the problems that we intend to have with these research projects are first of all to curb cheating in KCSE examinations, because we all know over the past few years there have been a rising number of cases of cheating in the actual examination. Secondly, we intend to uphold integrity and fairness in our examination. We intend to curb and stamp out some of the unfair practices that have been taking place within the examinations. As we are doing our research project, it was actually guided by a few research objectives. The first objective is to develop a system that will be able to accurately detect the presence of a mobile phone within a 5-meter range by having a wireless module that will be able to detect the radio frequency waves which are emitted during information transfer. Secondly, it will be incorporated with a buzzer enhancement module that can be able to provide instant alerts to the examiners or the relevant authorities about the presence of a mobile phone. Now, as we are doing this research project, we were required to go through an extensive amount of literature. And as we were going through the same literature, we did see that there was a very extensive research lab. Although there were previous attempts to make such systems, those systems would rely heavily on manual intervention through the use of invigilators. And as we all know, from the rising cases of cheating, this has become insufficient and inadequate. So in order to bridge this gap, we have developed this system by incorporating a GSM module that can be able to provide real-time alerts to the examiners. Now, some of the scientific principles that we use in the development of our model are, the first and most important is RF detection. As I previously mentioned, radio frequency waves are emitted during communication used by communication of smartphones. And our model will use a wireless module to be able to detect the RF waves which are emitted by phones. Secondly, we have signal processing. A normal 3G phone will use between 0.9 gigahertz to 2.4 gigahertz. So our model was trying to filter out all relevant bandwidths such as used by Wi-Fi, such can be able to be related to the relevant bandwidth. And finally, we have Arduino microcontroller programming. In order to program our Arduino Pro Mini, we have to use the Arduino IDE interface, which is a C++, which is based for the C++ language, which is also object-oriented. Now, let's move on to the apparatus which we use. In order to develop this model, we have the casing, we have some buttons here, we have the OLED screen, we have an antenna, and then inside here we have the actual wireless module. They come as a unit. We have a switch, we have the Arduino Pro Mini itself, we have the GSM module, a capacitor, and a buzzer. Now, let's move on to our demonstration. When the model is done, you can see that it gives you the option of a phone scan. Once it is selected, it will take you to this screen, which shows that in this room, it has detected 3 phones. So now we can see that the buzzer has actually gone off to inform us that there is the presence of the phone within the room. Now on the screen, we can see the number 3 has been displayed, showing that our model has detected 3 phones within a 5-meter range. Now when we come to our phone, we can see that an alert message was sent. So here's a sample of some alert messages that are sent. Once the phones are detected, once a phone is detected, an alert message saying phone detected is actually sent to the examiner's phone, which is assumed to be this. Now show that our system is real time, we can see that the number has moved from 3 to 7, indicating that the model has indeed detected more. Now we can see it's back to 3. So this proves that our system is actually real time. Now, although our system seems to be perfectly working, it does have some limitations. First of all, is GSM network connectivity. As we know, different regions in the country will have different levels of connectivity. So if it were to be in a very remote area, there will be very poor network connectivity. Hence, the duration of time used to send the alert message will be very long. Secondly, we have the limited detection radius. As we know, our model will only have a detection radius of 5 meters, but some examples can go up to 20 meters. Hence, making our model not work properly in such situations. So, from this limitation, we'd like to recommend future researchers to come and do more research, such as expanding the detection radius of our model, so that it can be able to encompass a larger area for larger examination roles. Secondly, we'd like to use a system such as Wi-Fi, which will not be heavily relying on the GSM network, which is far more expensive to get the GSM infrastructure, which is far more expensive to build. Now, before I finish up, I'd like to acknowledge the following who actually made this research project possible. First, I'd like to thank the Almighty God for giving me His grace and knowledge for me to be able to develop this model. Secondly, I'd like to thank our school administration led by our able chief principal, Mr. J.M. Mugai, who provided us with the resources necessary for developing this project. Last, then I'd like to thank our science patron, Mr. Stephen Abira, for assisting me in doing my paperwork and compiling my work. Lastly, I'd like to thank my ICT club teacher, Mr. Titus Minor, for assisting me with the technical bits such as the Arduino, microcontroller programming, and assembling of the model. Thank you.
Welcome to the 61st Science and Engineering Fair. My name is Usu Anthony from the Secondary School, Lam County, Costa Rica. And my colleague is
Precious Andy from the Valley Secondary School, Costa Rica.
ready to present a science project under category Energy and Transportation and entitled Free Energy Intercom. There has been a problem with getting water from the available sources in large families and communities, and also increase in the cost of living as they depend on electricity from water. There has also increased in environmental conditions leading to environment pollution. This has been resulted by use of fossil fuels. The fossil fuels lead to one, increase in global warming as there is increase in emission of undone hydrocarbon and carbon dioxide. It also leads to death of plants and animals, especially with those in aquatic areas, due to when nitrous oxide combines with water, it forms nitric acid, which is toxic.
The objectives of our project was to produce a pump that pumps water to a maximum height of 10.3 meters that carries all the atmospheric pressure and nanometer to the environment. It was also to reduce environmental degradation, which are caused by emission of fossil fuels to the atmosphere. And lastly, it was to reduce time wasting and also saving costs from universities. The apparatus used as follows: 4 pieces of 2 by 2 timber 12 feet, a piece of 200 meters metallic pump, a piece of 1 inch PPR pipe, which PPR means polypropylene pipe, a piece of PVC 2 inch pipe, PVC means polyvinyl chloride pipe, a piece of PVC 2 inch union, 2 pieces of PVC 2 inch elbow, 1 piece of PVC lollipop 1 piece, 1 piece 3/4 inch green bar, 1 piece 2 inch pinball, 2 pieces main adapter 1 inch, 1 piece of PPR 1 inch union, 2 pieces 3 inch PVC end caps, 2 feet 3 inch PVC pipes, 1 piece 1 inch hook bar, a piece of PPR 1 inch elbow, a piece 1 piece 1 inch gold cord, a piece of PVC 2 by 1 reducing bush, thread sealed 4 pieces, PPR each gun machine, a half kg 4 inch nail, 1 piece 1 inch union, tape measure, stopwatch, bucket, and paper.
The following procedure was first we make a stand 6 centimeter, 8 centimeter, and 2 centimeter tall. Clean the tank, remove all the contaminants. On the top of the tank, locate 2 primers, one located to the inlet, while the other to the outlet. In the inlet, there is a football inlet there, while in the outlet, there is a stabilizer. The stabilizer is used to increase pressure as the water is getting out. When fitting the PPR pipe, we use a heat gun. While fitting the PVC pipe, we use a dryer.
And let us take you through how our machine works. But our machine is outside there, so we will take you later to see how it looks like. Before using the pump, fill the tank until it is full using one of the timer and allowing the metron to remove the air inside. Fill the tank until there is no
control after connecting. You open the primer. After opening the primer, you fill the tank. Also, filling the tank, leaving one of the primer for air to escape which was inside the tank. After filling, you open the bolt top, then to get out. The stabilizer, the air which was inside the outlet, between the outlet, the bolt top to the stabilizer, gets into the stabilizer. After getting the stabilizer, it allows water to rush out with a high pressure, which water gets out continuously. Then after the water gets out the outlet, the water getting out, it comes from the tank. The water which is coming from the tank, it makes the balance of the atmospheric pressure inside the tank and outside. This makes the tank the food valve to suck water from the well directly to the tank and refill the space which was left by the water removed outside. This makes a continuous flow of water inside the tank and also out in the outlet. In our project, we had two variables, dependent and independent variable. The dependent variable was the weight of water on the dependent variable, as it depends on the depth or height of the water. As the height or depth of water increases from maximum of 10 millimeters, the water withdrawal reduces. The independent variable was that the height or depth of water determines the amount of water to be drawn from the source of water. Also, the time was an independent variable as it determines the volume of water to be collected. We were able to collect the following data. Collected this data of the height of water against the weight of the water collected and drew the following graph. We also collected the weight of water drawn in meter and against the time taken. We were able to draw the following graph. This graph, we calculated the gradient of our graph. We got that it had a negative gradient. This implying that the pump will not find water to a height of 10 meters, to a height of a gradient given by -10. This is because the pump will be having some errors, like errors in data collection, valve leakages, timing, and also measurement of the weight. In the graph 2, we calculated the power of our machine. As we calculate the power is equal to force times velocity. We calculated and got 1.67 watts. We converted the watts to horsepower. As we converted, we got 0.0024 horsepower. From our data, we can conclude that the height of water depends. The water drawn depends on the height of water to be drawn. Also, from our objectives, we were able to attain our objectives, like producing a pump that comes out at the maximum height of 10 meters and a conservative environment. Secondly, we were able to attain our objectives by reducing environmental degradation and also on reducing on time wasting and cost of fetching water.
We had to inform that part of the plant will be done by use of bigger pipe and bigger transmitter capacity. We would also like to acknowledge that firstly acknowledging our Almighty God for the gift of life. Secondly, I would like to thank our principal, Majengen Secondary School, replace the conventional body powders in the market. The conventional body powders in the market contain such harmful ingredients such as cancer, which affects the user negatively if used consequently. Yes, our powder here shows it was able to inhibit fungal growth, and also it was able to absorb the excess moisture in the liquid. Why? The reason why we came up with this project, yes, ourselves. Why do women use this powder? Women use this powder so that something that they can boost their self-esteem, and it also improves their confidence to interact with people. Our objective here was to determine if our body powder urea was able to absorb the moisturizing effect in the skin, and also to determine if it inhibits fungal growth.
To make this powder, we needed botanical ingredients which are all natural. The first one was almond powder,
which was used to kill acne.
second was cornstarch powder,
Which was used to absorb the moisture in the body.
third was kaolin clay,
We use kaolin clay because of its high oil absorbing properties,
and also used almond flour,
because it suited the skin,
also almond oil,
which is used to hydrate the skin,
and lastly vitamin C.
which protects the skin from damage.
All of these five powders were mixed together in a 1 kg plastic beaker with a wooden plastic. We used 18.5 grams of almond starch powder. We used 12.5 of cornstarch powder. We used 5.0 of kaolin clay. We used 2.5 of almond flowers, 0.5 of almond oil, and 1.0 grams of vitamin A. So all this together to form a homogeneous mixture, and ensure that all the oil are incorporated into the powder by mixing it in a coffee grinder. From making of the powder, we realized that our jewelry here had a sweet smelling aroma and had a relaxing feeling when applied. Yes, multiple reaction was sent to establish that our powder meets all the qualities of our standard powder, and we used MX as our standard powder compared to jewelry. We carried out for different tests. The powder was absorbed test, whereby this test was beneficial for us in order to know the effectiveness of our powder jewelry to absorb excess moisture in the body. From the results here, you can see that the absorbency rates increase with the increase in time when the photograph here. The second test we carried out was the chemical test, which was essential to enable us to know if our powder jewelry will inhibit fungal growth. From this, we needed help from Cambridge, now we got help from Professor Geoffrey Maina, who got us to connect these cells, help us to found cells. Yes, from our test, in the graph here, the number of cells counted from the Tachometer, different differences are increased inside, thereby our powder jewelry inhibits fungal growth. Our third test was the skin hydration level test, which was essential for us to know that our powder jewelry here will keep our skin dry efficiently. From the results we obtained from the hydration scale, the level of dryness of the skin kept on improving, whereby the skin was sufficiently hydrated as short of the hydration. The fourth and last test was the consumer test, whereby you use this test to enable whether our powder will be able to reduce the skin disease. From our side chart here, we were able to see that the self-esteem of women was boosted, and we conducted this test using 12 participants, whereby each of them were subjected to questions and for vaccine administration, and their questions, special expressions was noted in order to measure whether they have self-esteem. Yes, from all the tests conducted, we realized that our powder jewelry meets all the standard conditions of a normal powder, whereby it provides a fresh and clean sensation and application. It's not a smooth, waxy feeling. It also eliminates and inhibits fungal growth. In conclusion, our powder jewelry was able to show desirable characteristics which can easily replace the conventional powders in the market. For our recommendation, we recommend that further studies to be conducted so as to know the specific amounts of the ingredients in the powder, and also to learn to find out the other ingredients that can be added to the powder so as to increase its moisturizing effect. So this project we are calling